Welcome to Brain Vision.
Well, the enthalpy and specific volume at state 1 are determined from the given pressure and saturated liquid values from A5, right? From A5. So we have enthalpy at state 1 is equal to 340.54 kilojoule per kilogram, and also specific volume, let's call alpha 1, that is equal to 0.00103 cubic meter per kilogram, right? Well, the enthalpy at state 2 is obtained from the energy balance on the pump. So H2 is equal to H1 plus alpha 1 into P2 minus P1. Now let's plug in values. 340.54 plus 0.00103 into 3000 minus 50, and that is equal to 343.58 kilojoule per kilogram, right? Okay. Now the enthalpy and entropy at state 3 are determined from the given pressure and temperature with data from A6, right? We have H3, right, that is enthalpy at state 3, that is equal to 2994.3 kilojoule per kilogram, right? And then we have S3, that is entropy at state 3. Well, entropy at state 3 is equal to 6.412 kilojoule kilogram per Kelvin, right? And the quality at state 4 is determined from the condition that entropy at 4 is equal to entropy at 3. S4 is equal to S3, and the entropies of the components at the given pressure taken from A5, Q4 is equal to S4 minus S liquid 50 divided by S evaporation 50, and by plugging values, Q4 is equal to 6 point. So Q4 is equal to 6.5412 minus 1.0912 divided by 6.5019, and that is equal to 0.838. The enthalpy at state 4 is then H4 is equal to H liquid 50 plus Q4 H evaporation 50, right? And now let's plug in values. So we have 340.54 plus 0.838 multiplied by 2304.7 kilojoule per kilogram. So H4, that is enthalpy at state 4, is equal to 2271.88 kilojoule per kilogram. Well, this was part A, right? Now let us do part B. Now we do part B. Well, the net power output is determined from the heat input and output. So W is equal to M into Q in minus Q out. And this can be written as M into H3 minus H2 minus H4 minus H1, right? And plugging values, 35 into 2994.3 minus 343.58 minus 2271.88 minus 340.54, right? Multiply by 10 to the power minus 3 megawatt. That's megawatt, right? Oops, sorry. So let me write on here. So that is, the unit is megawatt, right? So this is equal to 25.25 megawatt, right? Okay, and now the thermal efficiency is determined from, now we do the thermal efficiency. Well, that is N is equal to W divided by input, Q input. So W divided by Q input is M into H3 minus H2. W is 25.2 times 10 to the power 3 divided by 35 into 2994.3 minus 343.58, and that is equal to, right, 0.272,